So our next topic is application of maximum minimum. That is the main application of derivatives. We can use the derivatives practically. How it is? Suppose we need a field, rectangular field, and we need the particular area, let us say 100 square units. 100 square unit area we need, right? And that area we need to protect from outside, so we need to fence it also. And for fencing, the wire is very costly. As wire is costly for fencing, we want that its perimeter must be minimum. Now condition is perimeter must be minimum, but with a condition what? With the condition that its area must be 100 square units. We don't want the less area. Area is fixed, so area is constant. So in the field, let us say x and y, we are taking its length and breadth. Now what length and what breadth we can take so that we'll get the area this and perimeter this. For example, we are taking a field of 20 and 5. 25, 100 is the area. Now perimeter for this is 50. If we are taking a field of 25, 4, then area is 100 again, and the perimeter for this is 58. See, the perimeter increased, area is same as per length and breadth. If we are taking length and breadth 10 and 10, we are taking length and breadth 10 and 10, then area is 100 but perimeter is 40. See, out of these three examples, we got the minimum perimeter here 40. So what dimensions we have to take to get the minimum perimeter where the area requirement is 100? This is the question, and this is the basic application, you can say. See, what to do is, let us take a field whose length is x and width is y, and area given is constant, that is 100. Area is x into y is equal to 100. See here, 2-3 things you need to note down here. Whatsoever is given, that you consider always a constant. Whatsoever is the given quantity, that is always a constant quantity. Like here, area A, it may be A, it may be 100 or whatever it is given, this is constant here, right? Second thing, whatsoever is maximum or minimum, like here we need the perimeter minimum. We need what? Perimeter must be minimum. So whatsoever is maximum or minimum, that we need to derive. That is to differentiate. That quantity we need to differentiate. And third is the thing which we are going to differentiate, that must be in a single variable. That must be in a single, that depends on single variable. If it is not in single variable, do it by using constant. Use this constant quantity to make it into a single variable. Now see, here perimeter is twice of x plus y. Twice of x plus y. It is in two variables, x and y both are variables here. So you can see x and y both are changing, right? So x and y both are variables. y is equal to 100 divided by x. From equation 1 you can write 100 upon x is from equation 1. Now p depends on single variable. P is the quantity we need to take it as minimum. That parameter must be minimum. So we have to differentiate this p. Differentiating with respect to the single variable here x. Only variable is x. So differentiate it with respect to x. For x it is 1. For 1 upon x minus 1 upon x square, 100 is constant as it is. Now is equal to what? Is equal to 0 for maximum or minimum both. This is the concept we know, that for maximum value or for minimum value this derivative is equal to 0. From here you will get the value of x. X square minus 100 is equal to 0. X is equal to 10. Minus 10, x cannot be negative as it is side. So x is equal to plus 10. Now see, when x is equal to 10, what will be the double derivative at this particular point? So double derivative for 1 0, for this minus minus plus 2 upon x cube, and x is 100, x is 10. This is what is positive. Positive means parameter is minimum at x is equal to 10. And if x is equal to 10, from equation 1, y is equal to 100 upon x, that is 10. So we got x is 10 and y is 10 for parameter minimum. This is what example we have taken. X and y was 10 and 10 for parameter minimum. So what was your question? Question was that 100 square meter field is required. 100 square meter field is required. Area is 100. Perimeter for the field must be minimum. So for what dimension it can be minimum? For what dimensions? For what length and breadth it can be minimum? So I told you, whatsoever is given that you consider constant, whatsoever you need to take maximum or minimum, like here perimeter, that thing you have to differentiate, and the differentiation thing must be in single variable. If not, then convert it into single variable. So area given was 100, that is length into breadth 100. Perimeter must be minimum, so perimeter is in two variable. We converted it into single variable by using this equation, by using this constant. We converted it into single variable. Then differentiate. For maximum or minimum, derivative is equal to 0. That is the concept of local maxima, local minima. That is equal to 0. From here you will get the value of x. If double derivative positive, then minimum. In case if it is negative, then it is maximum. So here we got it positive. So your parameter is minimum at x is equal to 10. So from this equation y also is equal to 10. Just note it down.